This is the solution for the online assignment 4, and you can see that this is something easy, because if you have really followed all the solutions of various problems, then this is a simpler one as compared to those ones. So here the switch operates at t equal to 0 and it opens up, leaving the inductor in a circuit uh, like a natural response circuit. And obviously this has nothing to do with that V naught after t is equal to 0. So this circuit is used to establish the initial state in this inductor. So before t is equal to 0, inductor would be short circuited. So what would we have? All these resistors would be there, but we will have a short here. Because of this short, all these are not going to matter. They are shorted out. If current is coming here, this side, it's not going to go here. All the current is going to go back here. So basically, this V naught at 0 minus would be 0. It's clear, but that's not the thing that we are interested in these circuits. Then we have to establish state. The state must be for the current flowing through the inductor. So here we are trying to find the initial value of current in the inductor. So it is just purely a DC circuit, a resistive circuit that is to be solved. We have to find this current. So what will this current be? We can solve it by a simple equation. You can solve it in many ways, but let me do it in a simpler way. I hope you understand that. So this is a resistor of 50 ohms, 50 ohm. These are basically not in the circuit. They are not connected at all. So it is just two resistors in parallel of equal value. So the equivalent resistance would be 25 ohm. This is 15 ohms. So the total resistance this source is seeing is 15 plus 25, 40 ohms. So how much current would be flowing out of this source would be 80 divided by 40, or 2 ampere. So 2 ampere current is going to come here, and it sees two paths that have the same amount of resistance in them. So it will split up, 1 ampere going here, 1 ampere going here. So what do we get? IL 0 minus is 1 ampere. So there is an initial downward current flowing in the inductor. So with this, for t greater than 0, we have an inductor with an initial current. So let us say this is ILT. Then we know the value of IL 0 plus is 1 ampere. And let us now use this knowledge to find the expression for V naught T. So IL 0 plus is 1 ampere too, because of the property of the inductor. So V naught T, using the general solution, would be e raised to power minus t by tau. So tau in this circuit would be the RL circuit, L by R. That would be 0.2 over 3 plus 2 plus 15, all are in series. That is what the inductor is seeing. It is 0.2 over 20. So what do we get is 0.01 seconds. And what is V naught 0 plus? Is initially there will be 1 ampere current flowing in this circuit. So V naught will be 15 volts. And at infinity, because there is no source in the circuit, obviously everything, all the energy is going to go out, and there will be no current flowing. So V naught infinity will be 0. So V naught T would be 15 e raised power minus t by 0.01 or 15 e raised power minus 100 t moles. I think this is it. No more, nothing else is to be found out.